Hello friends, today we are going to study about van der Waal interaction. So van der Waal interaction is the interaction which is based on the distribution of electronic charge around an atom. It changes with time. It is the weakest bond which is non-specific in nature and it is sensitive to distance. That means as you increase the distance, the interaction will go weaker and it will break. As you decrease the distance, you'll get more and more strong interaction. The bond strength is 0.4 to 4 kilojoule per mole. When two non-bonded atoms comes in close proximity, there occur arrangement of charges. Because of this arrangement of charges, you can see here that when two non-bonded atoms come close together, all the electrons get arranged at some point of time towards right. And in the next atom, because of this negativity, the positive nucleus got arranged towards the left. So here electrons, all the electrons at one side, negative, the nucleus, positive. So here negative and positive, they start interacting. Clear? So here the interaction is between two non-bonded atoms. The non-bonded atom can be polar, non-polar in nature. That doesn't matter because whether the substance is made up of polar or non-polar, it is made up of any element which is made up of atom. So in the atoms, the electrons and protons will be there. Electrons will be negative, proton is positive. So at some point of time, when they come in close proximity with each other, the electrons and the protons, they arrange themselves, due to which there generates a partial negative and positive charge, and hence they can interact with each other. Here you can see when the two atoms are very far from each other, there are no interaction among them. As soon as they start coming close, the interaction or the attraction increases. The distance at which they will be in their maximum attraction, that distance is known as van der Waal contact distance, which is 0.4 nm. At this distance, the van der Waal interaction will be the strongest. If they come more close towards each other, then again they will start repulsing because the nucleus and the electrons will overlap, due to which the same charges repel each other. So they will again repel. So distance is very important for a strong van der Waal interaction. The energy of van der Waal forces can be calculated using the formula delta G is equals to A upon R to the power 12 minus B upon R to the power 6 plus Q1 Q2 upon R. That means van der Waal interaction depends upon the radius, that is the distance, and the charges present on them. The first A upon R to the power 12 is the repulsion force, which should be minimum. B upon R to the power 6, it denotes attractive force, which should be maximum. As the R decreases, the attraction increases. If the R increases, the attraction decreases. Now, types of van der Waal forces. One is dipole-dipole interaction, which is also known as Keesom interaction. That means already the two atoms have some dipole moment on them. That means the two atoms, or we can say the two interactive atoms, already carries charge in them, positive and the negative. So already they are in a dipole condition. That means one positive end, one negative end. Here also one positive end, one negative end. So they can interact. So dipole-dipole interaction happens between two atoms which are already in a dipole state. That means positive and negative already segregated at two ends. Dipole-induced dipole interaction, which is also known as Debye forces. Here, one atom is already in a dipole state, means they carry partial positive and partial negative charge. Due to this dipole nature, when the other atom, which is not in a dipole state, gains dipolarity and then they start interacting, then that type of interaction is known as dipole-induced dipole interaction. And the third is known as induced dipole interaction. That means both the atoms or both the elements participating are not in a dipole state, but because they are close enough, the electron starts arranging, and due to which they gain dipole character, and hence they can interact with each other. So this type of interaction is also known as London dispersion force. Now, what are the factors that affect van der Waal forces? First is number of electrons. Down the periodic table, we know the atomic radius increases. That means number of electrons also increases. So more the number of electrons, more they can contribute to dipole moment. Next is shape of the molecule. Long unbranched molecule have more dispersion force. Short branched molecules has less dispersion force. Here the figure is of lizard, wall lizard. How a lizard can hold itself against the wall? That is because of this van der Waals force only. The atoms of the lizard body and the atoms present in the elements by which the wall is made up of, because of their close proximity, they get dipole nature and they start interacting, and because of this only the lizard can walk in a vertical wall. Now, one question from my end for you all is you have to answer the question where you can find van der Waals interaction in a biological system. Do write me in the comment section. If you found the video informative, please do like, share, and subscribe the channel and hit the bell icon for the next video notification. Till then, stay safe, stay healthy.